Here is a little more information for you on circles. In the previous video, I talked about how to have the equation of a circle in standard form where you can see the center and the radius, and then changing it to general form where it all equals 0. And in this video, we're going to show how to go the other direction. In example 4, we have an equation given to us in general form because everything's on one side equal to 0. So this is the general form of this equation, but you can't just look at that equation and immediately see the center and the radius. In order to see it, to be able to see the center and the radius, you need it to be in the form x minus h squared plus y minus k squared equals radius squared. In order to get there from here, it's going to involve the process that we've done before, completing the square. So here's what you have to do. You have to arrange all of the terms so that the x terms are together. So x squared plus 2x. And I'm going to complete the square and make this a perfect square trinomial here in a minute. So I'm going to leave a little bit of room. Plus y squared plus 4y. And I want to make that into a perfect square trinomial. And I know when I'm finished it has to equal a radius, and negative 11 is not the right number to make either one of these a perfect square trinomial. So I'm going to start and add 11 to both sides, and now it equals 11. I want this to become a perfect square trinomial. That requires that I add just the right number, and we know we can do anything we want to an equation as long as we do the same thing on the other side. So if I'm going to add a number on the left, then I'm going to also add a number on the right. And I want to complete this square, so I'm going to add a number here, which means I'm going to need to add another number over here. Now you remember how we found the right number to add? You always take half of the middle term and then square it. So a half of 2, that means a half times 2 is 1. And then if I square it, 1 times 1, I know I need to add 1 right here. If I add 1 on the left, I got to add 1 on the right. Draw boxes so you don't forget to do that. That's where people mess up on these problems. What will make this a perfect square trinomial? Half of the middle, 2, and square it. So we added 4. If I add 4 on this side, I must remember to add 4 on the other side. Now, this will factor. It's a perfect square trinomial. It factors as x plus 1 times x plus 1, or x plus 1 squared, plus, this will factor, y plus 2 squared equals 12 plus 4, 16. This equation is now in standard form. And the nice thing about having it in standard form is you should be able to look at this and immediately tell me what is the center. This means everything shifted opposite of what you think, left 1. So the center is at negative 1, opposite of what you think because it's in parentheses. So plus 2 really means it's affecting the y's. It goes down 2. So negative 1, negative 2 is the center. And we said the radius squared always shows up in the equation. So the radius squared is 16. Take the square root of both sides. And then the radius is 4. And if you know the center and the radius, you can make a little sketch of the circle. If I ask you to sketch this circle, here's what you would do. You're going to first label the center, negative 1, negative 2, and you want a radius of 4. So go 4 in all easy to graph directions. 1, 2, 3, 4. And from here, 1, 2, 3, 4. And a radius of 1, 2, 3, 4 this direction. And 1, 2, 3, 4 this direction. and then draw the circle. Pretend that looks like a circle. Here's another one. In this example, you have an equation in general form. The disadvantage of general form is you can't look at it and immediately see what the center and the radius is. So we're going to put it in standard form. And the process involves completing the square. We want to group together all of the x's and then group together all of the y's. And on this one, there's only one x value. So I don't have enough terms to be able to complete the square for x's. But I have y squared minus 5y, and negative 8 is not the number that I need to complete this square. So the first thing we really need to do is add 8 to both sides and make it equal 8. So I can't, there's not enough for me to complete the square here. But I have two terms here, so I have enough terms to turn this into a perfect square trinomial if I add just the right thing. And whatever I do on this side, I can't forget I have to do the same thing on the other side. Now, fractions are your friends, remember? The process is still the same. To figure out what I need to add, I always take half of the middle. So a half of 5, a half times 5, that gives me 5 over 2. And then when I square it, 5 halves times 5 halves turns into 25 straight across the top over 4 straight across the bottom. So the right thing that we need to add is 25 fourths. And whatever we do to one side, we need to do the same thing to the other side. Now, x squared all by itself doesn't really factor, but I could call it x plus 0 squared. This trinomial will factor. It factors as y minus, because I need a minus in the middle, and the square root of 25 fourths, y minus 5 halves all squared equals, in order to add these two, I would have to have a common denominator. That's 4. So I need to change both of these to be something over 4. 1 times 4 means do 8 times 4, so we have 32 over 4 plus 25 over 4. And we can add only on the top and keep the denominator. So the standard form equation of the circle is x minus 0 squared plus y minus 5 halves squared equals 61 fourths. And that's not, I think I missed a sign. No, I didn't miss a sign, I just misadded. 57, not 61. I had right. 32 plus 25, 57. I don't know where I got 61. I beg your most humble pardon. So now you can tell me what the center of this thing is. It is centered at, it didn't shift any left or right, so the center is at 0. Y minus 5 halves means that it shifted opposite of what you think, so up 5 halves. The center is at 0, 5 halves. Remember in the equation, this is the radius squared. So the radius squared is 57 fourths. And when you take the square root of both sides, the radius is the square root of 57 over 4. But remember that when we have a square root of a fraction, we can pull it apart and think of it in pieces. So the radius is the square root of 57 separate from the square root of 4. And there is a square root of 4. It's just 2. 57 is a prime number. So there's not much you can do with that. Here's the center. And the radius is exactly the square root of 57 over 2. If you wanted to graph this, you would have to get a decimal that means about the same as this. So if you type square root of 57 into your calculator, enter, then divide it by 2, if you had to graph it, the radius is approximately 3.77. Or you might call it about 3.8. And then you'd have to just kind of do the same thing we did here, but kind of guesstimate how far 3.77 is. Here's one more example. This is example 6 on your notes. And we're asked to write the equation of a circle, x squared plus y squared equals r squared, or with a shift, x minus h squared plus y minus k squared equals r squared. That's standard form. Here's what we know. We're trying to write the equation of a circle. We know that -2, 5 and 2, -3 are the endpoints of the diameter. Remember, a diameter passes right through the center of the circle and has its endpoints on the circle. So, and it looks like it goes through 0, 0, but don't assume, because I don't think I had it graphed exactly accurately. Because it shouldn't pass through it shouldn't pass through 0, 0. So we need to know 2 things, and after we get finished, it says express it in general form. The 2 things that we have to know in order to write the equation are the center and the radius. In order to find the center of the diameter, or the center of the circle is the midpoint of the diameter. So remember what we did to find the midpoint. The midpoint is the average of the x's and the y's. So if we average, we'll add and divide by 2. Add, remember, -2 plus 2 divided by 2. And 5 plus -3 divided by 2. So 0 divided by 2 over 2 divided by 2. That means the midpoint of this segment is at 0, 1. And so that point right there, the center of the circle is at 0, 1. In order to find the radius, we have to know what's the distance from the center to this point, or the center to this point. Or we could even find out how long is the entire diameter, but then we'd have to divide it by 2. So I would recommend to find the radius, you calculate the distance from center to one point on the circle. If we say, well, let's do this one. Let's calculate the length of this radius. I gotta know how far is it from 0 until I'm lined up with 2. Because if I draw a right triangle here, if I'm going from an x value of 0 over to an x value of 2, that's really 2 minus 0. This length right here, I'm working in a triangle, and I know this length is 2. How far is it from 1 down to -3? Well, it's 1 minus -3. I'm really plugging into the distance formula, but it's just as fast to think Pythagorean theorem. 2 minus 0. Doesn't matter which order I subtract, because I'm going to square these in a minute anyway. So how far is it from 1 down to -3? It's a distance of 4. So how long is the radius? In order to find the radius of this circle, we have to do 2 squared plus 4 squared equals radius squared. Or 4 plus 16 equals radius squared. Or 20 equals radius squared. And what's the radius? When you take the square root of both sides, there's a perfect square hiding inside of 20. 4 times 5, so it's 2 times the square root of 5 is the radius. Once we know the center and the radius is 2 square roots of 5, the standard form of equation of a circle is x minus h squared plus y minus k squared equals r squared. But I need this circle to shift none to the left or the right, so x minus 0, it'll just be x squared. But I need it to shift up 1, so that's going to make it have to, in order to make the graph shift up 1, it'll have to be y minus 1 squared, and it equals the radius squared. So it equals 2 times the square root of 5 squared. Well, I know from right here, before I took the square root of both sides, if I square 2 square roots of 5, if I square this, 2 times square root of 5 times another 2 times square root of 5, that gives me 4 times square root of 25, or just 4 times 5, and it gets me back to the 20 that I had right here before I took the square root. So x squared plus y minus 1 squared equals 20. This is the equation of the circle, but this is standard form. So if we need the general form, we know that we have to expand it all out. I'm going to come back over here to finish it. If you have x squared plus y minus 1 squared equals 20, and you need to put this in general form, then you got to think of this as x squared, and then you got to expand y minus 1 times y minus 1. And we know in general form, I'm going to have to subtract the 20 to make it equal 0. So x squared plus, this will give us y squared, negative y and another negative y makes it negative 2y, last times last, positive 1, minus 20 equals 0. Or x squared plus y squared, there's no x term, minus 2y, and 1 minus 20 is minus 19 equals 0. This general form means the same as the standard form. The standard form makes it easier to see the center, 0, 1, and the radius, square root of 20, or 2 square roots of 5. But sometimes you're asked for the general form. So there it is.